Hello everyone, welcome to the first video of my Docker series. In this series, the focus is going to be on how to Dockerize a real-world full-stack Spring Boot application from start to finish, step by step. The application that I'm going to use is my own personal application that I created from scratch. We'll Dockerize the backend, the front-end, and MySQL database, and organize everything so it runs clearly and consistently using Docker Desktop and Docker Hub. Now we will take a look on the Dockerfile that I created for my Spring Boot backend and explain each part and what does it actually do, so you can clearly understand how it works. So the Dockerfile that I'm using is written with something that is called multi-stage build, which is the best practice in Docker. The goal here is simple: turn our backend into a Docker container that can run anywhere. We will do this in two main steps. First step, build the application. Second step, run the application. Starting by step 1. Here we choose an image that already has Maven and Java 17 installed. Why do we need this? Spring Boot needs Maven to compile the project, and Java 17 is the version used by the backend. We name this stage build because it will only use to create the jar file work there/app. This line creates and uses a folder called /app inside the container to keep the project organized and allows all the commands like copy and build to be executed inside this folder. And last but not least, when we copy files, Docker knows exactly where to put them. Here we copy the pom.xml file into the container. You might be wondering, why do we need to copy it? So basically pom.xml contains all the project dependencies, and Maven reads this file to know which libraries to download. So without this file, Maven cannot build the project. It means we need this before building the app. After copying all the dependencies, now we copy the rest of the backend code source. This includes the Java files, configuration file, and the resources, because Maven needs the resource code to compile the application. Without copying the code, there would be nothing to build. At this point, the container has the project configuration plus the full backend code source. Run Maven clean package disk IP tests. This command tells Maven to build the application. Let's break down this command. So clean removes all build files, and package compile the code and creates a jar file. For disk IP tests, skip tests to make the build faster. And why do we need this? The goal is to generate the final jar file that will run later inside the Docker. After this step, the jar file is created inside the app target. After building the application, let's go ahead and make our second step and run the application from Eclipse Tamarin 17 JDK. This starts a new stage because we don't need Maven anymore. We only need Java to run the jar file. This makes the final Docker image smaller and cleaner because it will be the only image that will be used to run the application. Again, we set the /app. We set it as a working directory. Since each stage is separate, we need a working folder where the application will live. This is where the jar file will be placed and executed. Copy from build. Now this line is one of the most important lines. We copy the jar file created in the build stage and we rename it to app.jar because we only need the final jar to run on the app. We don't want the source code or Maven in the final image. This keeps the container lightweight and secure. For the expose 8081, this line tells Docker that the application runs on port 8081 because Docker needs to know which the available port. Also, when we connect containers or access the app from the browser, this port will be used. Now for the last command line, this will start the application. So when the container starts, Docker run this command. Java executes the jar file and the Spring Boot backend start running. Without this line, the container would start and immediately stop. So what we did with this Docker file, we built the Spring Boot backend, we generate a jar file, then we run the backend inside the container. Now the app works the same way on any machine. That's it for today's video. In the next one, I'll show you how to Dockerize the front-end application step by step. See you in the next one.